Hello everyone. In this video we're going to be taking a look at several rare and beautiful motors which were manufactured by the Jeannin Electric company based in Toledo, Ohio. The company was founded by Harry Jeannin in around 1919. Prior to starting his own company, Mr. Jeannin worked for Century Electric, and then in around 1916 he came up with some of his own designs, pulled some patents, and he wanted to get his own motors into production. And in 1919, when he started his company, that's what happened. The company was in business for less than 10 years, and Mr. Genan died in around 1929, and the remnants of his company were sold to Howell Electric. There's very few surviving examples of Jeannin Electric motors out there. One of the reasons for that is that although these motors are exceptionally powerful, they're prone to breakage. These Endbells are thin, and the open design, they crack real easy. So if you were to do a Google search, you would come up with less than 10 surviving examples that you could find on Google anywhere, 3 of which are sitting in front of you. So it's highly likely that you've never even seen this motor before, this type. So the focus of the restoration in this video is going to be this middle motor because it has the most damage. This motor was dropped, the Endbell is completely cracked up on it, it's been repaired. It's missing a front leg on the base. It's completely missing. So it needs a lot of work, and I think that you're really going to enjoy following along on the restoration of this beautiful piece. So I'll bring the camera in here and we'll take a closer look at the ones we have on the table. The first one we'll take a look at is this 1/4 horsepower version. This thing's really heavy. It weighs over 40 pounds. It's very substantial for a 1/4 horsepower motor. I've already taken this motor completely apart. You can see I got my tag on it there. I made new brushes for it. I replaced the springs, both on the brush holder assembly, and I had to make some modifications to the large spring, which controls the movement of the shorting necklace. I took the commutator out, I trued it up on the lathe, re-undercut the mica sections in between the segments there on the commutator. It's really a nice running motor. Let me turn it on for you and check it out. Smooth and quiet, just what we like. This is a 1 horsepower model, and it's currently wired for 220. All that wiring needs to be completely replaced. It's all falling apart. I haven't done any work to this motor, so it's just as I received it. It does run, but it doesn't run great because it needs to be gone over. But I'll start it up on the Variac here. Because it's wired for 220 and we're starting it up with 120 volts, it takes longer to reach induction mode, of course. See, there's some arcing in those brushes. There we go. Once it reaches induction mode, you can see it's nice and quiet. So this one will be next on the list to get the treatment it needs. And we'll shut her down. Alright, now we'll move on to the main project for this video. Okay, so a couple things I wanted to point out on our subject motor here is that when I move this rotor by hand, you could hear a lot of clunking around in there. Now there's weights in there, but those weights should be held in place with the spring, and they seem like they're looser than they should be. They shouldn't be falling like that. Hear that? Now, when I come over here to this one, right, same motor, and I turn this, listen, it's perfectly quiet, okay? The weights in there are held in place with the spring. That's how it should be. So something is definitely not correct with this other one. The other thing that I notice on this one is, here's our shorting necklace right in there, you can see it. Now, when I move the rotor by hand, you'll notice that the commutator moves and not the necklace. See that? There's like a backlash in there. So the rotor is moving, but the shorting necklace isn't. That's not right. When I come over here to this one, okay, here's the shorting necklace. I know it's hard to see in there, but you see, that's locked in. Those are engaged. So when the rotor moves, the shorting necklace moves. There's no backlash, so to speak. So I don't know what's going on internally with this one, but something definitely doesn't seem right. So anyways, when we open it up, We'll see if we can sort out what's going on. The other thing that I'll point out real quick is this one appears to have some kind of ball bearings. If you notice, it has the square housing here, whereas the other one has the sleeve bearings. So that's just something to point out. Anyways, let's get started. I got the motor heaved up onto the workbench here. A couple problems that we're going to need to overcome before we even get this thing taken apart is, first, whoever did the repairs on this, they welded the Endbell onto the Stator housing. You see that weld repair right there? Here's the line where the Endbell should pop off, and the weld extends beyond it. Same thing up here. Okay, the Endbell is welded onto the Stator housing, so I'm going to have to take a cutoff wheel. I'm going to have to cut a groove in there so that we can get the Endbell off. That's problem number one. Another thing is that when I picked this motor up, you know, I got this motor on Facebook Marketplace. It was getting ready to go to the scrap bin, and I felt sorry for it, and I saved it. Anyways, when I was getting the motor into my vehicle, a screw fell out of the Endbell housing, of which I have here. I have no idea where it fell from. I don't even know for sure if it's from this motor. So that's something that we'll keep an eye out if we come across any missing screws. I do have one that fell out of the Endbell when I picked it up. Also, this pulley is in bad shape here. Okay, a shim was put in here because the hole on this pulley wasn't the right size for the shaft. But the key right here, okay, it's completely slid out of the groove. And this thing is wedged in there really, really tight. And this whole thing obviously is completely rusted solid. So I'm going to have to try to get this key out of here and see what it's going to take to get this pulley off of here. I'm going to have to file this down a little bit. This shaft is pretty snookered up right here. So I think we'll go ahead and first thing I'm going to do is I'm going to get out the Dremel. I'm going to trim up this weld here so we can get that back Endbell off when the time comes. And then we're going to focus our attention on trying to get this pulley off of here, which is going to be a job. So let's get set up to do that. Try that. Let's go to the next one. Getting that key out of there was the most difficult part. Once I got that out, the pulley actually pulled off using the puller pretty easy because the sleeve that the guy put underneath there was a copper sleeve. So fortunately, it wasn't rusted onto the shaft. So I didn't record the whole thing of me pulling that key out of there because that took about 15 minutes. Anyways, we're going to go ahead with the disassembly and try to get these Endbells off of here. I cleaned up the high points on the shaft using the file. You can see that this thing is in bad condition. Before I try removing the Endbell, I want to take off this bearing housing and just look inside there. Just want to see what we're dealing with here. And then once we know that, we'll try to take off the Endbell.
Okay, there's our bearing. See if I can clean out some of that gook out of there. I can tell you one thing, that bearing's been in there for a long time. Okay, I got those screws sprayed up with some liquid wrench. That wasn't too bad. Okay. Now what we want to do is try to carefully tap off this end bell, and I do mean carefully as not to fracture this. As I mentioned earlier, these end bells are real thin and they can crack real easily. That's one of the reasons why you don't see very many of these around. It's probably the main reason. My hand's in the way, I apologize. Okay, we are getting some movement. Well, let me get the chisel out and tap this thing off. I'll bring you guys back. I want you to take a look what we're dealing with here. Look at the condition of that. I mean, oh my goodness. I mean, this may be the most challenging project I've ever taken on here. I mean, right now I can't get these end bells off of here. I'm going to keep playing with it. Now, I think that this is like a retaining nut. You see the way that that's destroyed there and there? There was probably supposed to be a spanner wrench or something going in there that unscrewed that, and it was probably frozen on there. Anyways, I'm going to see if I can persuade that off. I don't want to use a whole lot of heat on this thing because, you know, it's not a good idea to heat up this rotor too much where you could damage the wiring inside of there. So in a situation like this, you know, when you're working on something that's 100 years old, you're trying to work with a minimum amount of heat and a minimum amount of damage to the structure here. So let me fiddle around with that and I'll bring you guys right back. Okay, here's that piece. I mean, holy smokes. So we're going to have to machine a new one of those. Now, I've been carefully, and I do mean carefully, tapping the shaft with this brass drift, and I did get some movement out of that end bell. You know, these pieces are already repaired. I'm trying not to crack that thing into a million pieces because it would be real difficult to braze or weld this back together to get the alignment perfect so that the rotor doesn't rub on the inside. So I did get some movement out of it. And now, there it is. Okay. And we did not break the existing repairs on there. That's really the challenge. I mean, this is an extremely delicate end bell. Reach and set that over here. Here's our brush holding mechanism. Okay, it's a brush lifting design, not unlike the Century. All of the fingers are completely retracted in there, so it seems like that mechanism hasn't worked correctly in a long time. Alright, so let me see if I can get this front end bell off. Let me play with this because I know that bearing's frozen on there, and we'll bring you guys back. All right, well, that took several hours to get that off of there. The fact that we got those bearings out of there without cracking those end bells into 20 pieces is an absolute miracle. I mean, after going through what I went through to get that thing apart, I can see how easily it would have been for somebody with a heavier hand to break that end bell up like it was. So anyways, this was really a difficult job, not in the mechanics itself, but in getting the job done without breaking anything. That's always the most difficult part of these projects, and this one was exceptionally difficult. But we got it apart, and we didn't crack the end bells any more than they've already been damaged in the past. So, I mean, these bearings haven't been out of here for a long time, I can tell you that. There are some leather washers that are held in there with some retaining springs. Here's a look at our rotor. As I mentioned before, that shaft is snarled up pretty good. There's the shorting necklace. There's the spring. Looks like we're going to need to make a new spring on that. Anyways, we'll take a closer look at that a little bit. We got our tags off and didn't damage them in the process. Took some fooling around because one of those screws busted off on me. Here's the tools I used to do that. Now we're going to set up and try to get this terminal block off of here. We might end up making a new terminal block anyway because this thing's delaminating. Looks like it's just a block of wood or plywood or something. How about that? Okay, well, that went much easier than expected. Sometimes you get lucky. It's a nice cast iron piece. Okay. I'm going to try to take off this terminal block here where these other wires come through. We'll have to cut the wires before we'll be able to take that off there, but I'm trying to get the bolts out. Okay, we got some movement on that one. There's a nut behind there. All right, we got the terminal block off. Now, if you look here, there's some retaining nuts here. And I believe the purpose of those is so that we could take this ring out, and that ring helps to retain the stator windings in there. If we can get that ring out, that'll give us better access to those windings to clean them and do any repairs to the wires. So we're going to try to take that out. I'm sure this is the first time in 100 years that's been removed. I did put a little red paint right there just to mark where the top of the ring was. When we put this back, we like to put everything back exactly the way that we took it out. So these nuts are slotted. So we're gonna let's see. Okay, well, that one came out all right.
All right, getting these 4 bolts out of the base of this motor and getting these connecting rods that run through the stator housing was a bitch. You're watching a video that's like a summary, but this took hours to get these things out of here using heat and hammering and drilling out a couple of them. Anyways, I finally, with the wrench around the screwdriver, this is the last one. And let me tell you, that was a job. Boom. Okay. Okay, I got my gloves on here because this housing is still a little hot from the torch, the base I'm talking about. Let's see if we can coerce that off of here. First time that bad boy's ever been off. Okay. Okay, I was able to lift this ring off of here. I had to push those windings in just a little bit to get it off. But there it is. Now the reason why I wanted to take that off so badly is if you look here, everything on these windings is completely dry rotted and falling apart. All this insulation, everything. I mean, as soon as you touch it, it just starts breaking apart. So my goal is to remove all those old wrappings, revarnish the windings, and then re-wrap them so that I could do a thorough job on it. And it's a lot easier to do that with those rings off. With the rings in place, you know, it blocks your access to the windings as far as re-wrapping them is concerned. So all this insulation here is going to be removed. It's just completely falling apart as you touch it. So anyways, now we're going to take a look at the other side. We got both of the rings off. That was a hell of a job just getting to this point. Now the painstaking process of removing all this dry rotted material begins. It's going to take hours to get these windings cleaned up and to get all that old material off of there. But it has to be done so that we could begin the process of wiring on some new leads. So I'll just go ahead and do that off camera. I'm not going to film all that, but I'll bring you guys back when this part of the job is finished. Here you can see the progress we're making removing these wrappings. So I've removed it here and here. I'm about to start here, and you can see how this is just completely coated with grease and oil. I mean, look at that. So now this is only the removal of the wrapping. After I get all the wrapping removed, then the whole thing is going to be cleaned up. I'll probably use a pressure washer on this because it's so bad. I'll bring you guys back as we make further progress. We've cleaned these windings as far as we're going to clean them, and they still look terrible. This motor has already been taken in the past and been rebuilt. You can see that red there where the windings have already been recoated. Any further cleaning will just remove insulation instead of cleaning it further. There's a lot of areas that have bare wire exposed. I mean, this thing is really one step away from the scrap heap, to be honest with you. These windings are in terrible condition, but they're clean. We're going to take it over. We're going to start drying them out. We're going to make sure that we get these things bone dry, and we'll see if we could bring up our mega reading a little bit. I did do a mega reading on it before, but the mega reading was completely in the toilet. showing that it was unsafe to run. So we'll see if we can bring it back from the dead.
Out with the heating pad for a couple days, but it just wasn't getting them done. I needed to get them a little bit hotter. They're just in such poor condition. I really need to get them hot and dry. I moved on to the car battery charger and I hooked them up to 12 volts with about 6 amps running through them. And that got them warm, but it didn't get them quite hot enough. So then I switched over to alternating current using the Variac. You can use alternating current to warm up the windings also. It just requires a little bit of a higher voltage than if you hooked it up to the battery charger. So I have my kilowatt on there and I had it set up so I was watching how much amperage I was putting through the windings. And this is rated for 9 and 18 amps respectively, depending on if it's on 110 or 220. But I found that about 9.5 amps, even sometimes close to 10 amps, really was the sweet spot for getting these things hot. I wanted them between like 135 and 145 degrees, where they were hot but not hot enough to damage them. And I used a digital thermometer and infrared thermometer to keep track of that. So I made sure they stayed right within range. And I had these things drying out for about a total of 4 days. It really took a long time to get them bone dry. When I first started using the Mega on them, the Mega reading was all the way almost at 0. I mean, I was getting nothing on it. So I'm going to hook up the Mega to it now, and we'll take a reading. All right, here we go with the Mega. We started out close to the 0 line. Now, after our persistence, let's take a look if it paid off. How about that? Infinity, baby. Boom. Just like that. In between doing the other stuff, I've been doing some of the grunt work, taking the paint off the castings, doing some wire wheeling on the parts, things like that. I'm not going to use up a lot of the video showing that part. You kind of get the idea. Got the inside of the motor masked off. We have a little bit of heat shrink applied just to the very base of where the leads are coming out. Now we got the motor hooked back up to the Variac. I want to get it nice and warm and toasty. And then what I'm going to do is my plan for varnishing the windings is I'm going to saturate it first with the spray-on EL600. After that is applied, I'll warm it back up with the Variac and kind of bake it on there internally. Then I'm going to hit it with a little bit of black spray paint just so that the windings look better. After that's done, then we're going to use a clear brush-on insulating varnish and put an additional heavier coat on there. And once that coat is applied, I'll do the same thing. I'll heat it up with the Variac to kind of bake that varnish on there. So we're going to get started on that right now. Got the windings back inside it, got them set up on the Variac. We're going to let them bake for a number of hours and really let that varnish cure. Really looks great. So we'll just leave it be. It's time to apply the clear insulating varnish. I'm using the Gliptol 1202. It's an excellent product. I've already got these windings nice and hot. I had them heating up. I'm going to apply a liberal coating of the varnish and then I'll get them reconnected so that that varnish could bake on there for several hours. Got this side of the windings wrapped up with the linen tape. Now I'll apply another coat of the insulating varnish over this and that'll lock that wrapping into position. Got a good coat of varnish over the wrapping. Now we're hooked back up to the heat. We'll let that cure, and that'll solidify everything into place.
I'm working on a couple of these terminal blocks. I thought this was a piece of plywood at first, the way that it's kind of delaminating there. So when I started cleaning it up a little bit, it looks like it's a piece of micarta or something like that. So I just put a little clear coat on it. I mean, just cleaned it, clear coated it. We'll just use the other side and call that good. This other terminal block here, where the 4 wires come out of the base of the motor, half of that was missing. You know, a big chunk was cracked off. So I put some tape on here. I got this filled in with some JB weld, and we're going to see if we can kind of shape the other side that was missing to blend in. We'll repaint that and try to reuse the original one. All right, we're going to start attaching the new leads onto the existing wires here. And this is a heavy gauge wire. So in order to make it a little bit easier to wrap it around that solid gauge wire that's coming out there, I'm going to anneal it just a little bit, which will make it more pliable so we can wrap that around there to solder those together. And now we're carefully going to wrap these around there. I've already cleaned this other wire here. This is where the annealing comes in handy. Now that we have that wire wrapped around there, we're going to brush on a little bit of flux, which will help our solder adhere better. Okay, we're coming in with a little bit of solder already on the tip of the soldering iron. Hold that on there, get that wire nice and hot, and then once we start it feeding, this is going to require quite a bit of solder because it's a pretty heavy gauge wire. That's okay. We don't mind that. We just want to make sure we get a nice good connection. Now we're just going to work our way down. That's pretty good right there. That looks pretty good. Now we're going to come in with our heat shrink tubing. Over there like that. To facilitate reinstalling these spacing rings, I cut them in half. The reason why I did that is I had to manipulate these windings quite a bit to get the rings off of there in the beginning. But now that they're nicely insulated, we got an infinity mega reading, I don't want to bend them and manipulate them putting the rings back on. It's not worth it because it could crack the insulation and ruin all the hard work that we put into these windings. So the purpose of these rings is they're only an interface between the Endbell and the Stator, so cutting them in half isn't going to hurt anything. So I'm going to cut them in half. That way I could just slip them right over, and that'll make the job a lot easier, and it won't damage the insulation on the windings in the process. We're going to start with the installation of the spacing rings. I got some F-clamps on there to draw that in tight, and I know how far to draw it in because the holes for the nameplate, those holes are lining up. So that's exactly the right amount of pressure on there. Now, before I put these connecting rods in there, and I did make the ones that were missing, I'm going to coat them up with a little bit of anti-seize lubricant. So in the future, if I ever have to take this thing apart, or somebody else does, they'll have an easier time of it than I did. So I already got those lined up. Now we're just going to use a drift. Tap that bad boy in there. Nice and gently. Okay, that's firmly seated. Once I get a couple of them in there, hold things in place. Now, the nuts will go in here. The nuts could only go in from one side because the other side of the threaded rod is, the nuts are tacked on there. Just gonna snug this, but not over torque it for right now. Go around later, snug everything up. The bottom half of this ring has a couple holes in it, which the wires exit out and they go into the base of the motor. So let me get these spacing rings on there. We'll bring you guys back. In addition to constructing a new foot for the one that was missing on the base, I'm also in the process of reinforcing the pre-existing repairs that were made to this Endbell. You know, these aren't the neatest repairs, but it's not easy to repair an Endbell like this that's cracked in a bunch of places because you have to get everything lined up perfectly so that the rotor doesn't rub when it's spinning around, and it's not that easy to do it. And the argument could be made that you'd like to see this brazed instead of welded, but it's been holding up all this time, so I'm just going to work around it. And I've drilled in here and in here, but those screws are sunk into the body there. And then you got 4 bolts here, and I have a piece of steel behind there that's acting as a brace for that. And then once this is all done, I'll take my die grinder and smooth that out a little bit and just touch it up with a little JB weld. That'll be strictly for cosmetics. Got our repairs finished on here, and they're really nice and strong. Tried to cosmetically make them look as good as possible. You can see there I tried to, you know, cover up a little bit all those previous welds. Plus we got all that bracing underneath there. I mean, it's as strong as it's ever been. There we got a reconstructed foot. So we'll do a little more massaging to it and get it painted up, and we're going to call that good. So here's our completed end bells and the base. I sprayed them up with that VHT wrinkle paint, which is great for concealing minor imperfections. And honestly, if I didn't tell you about all the repair work we did to those, you'd never know the difference. So I think they came out looking great. Moving on to the brush holder assembly, the design of this thing is not unlike the Century motor. One thing you could see right off the bat is these springs and these little fingers are completely corroded. So this is all frozen here. These brushes are supposed to be able to move up and down in those holders with the springs, and that's not happening. So there's no way that the motor could run without those things being freed up. So we'll start taking it apart, get it going again. Okay, I found one explanation why these brushes were not operating. So if you look at this one here on the left on this finger, you could see that that's a nice straight angle. If you look at the one on the right, you can see that that's cocked over at like a 45. If you look at the top there, you can see that that's flat. You can see that this one is all smashed up. So what happened with that is the fingers were all corroded, okay, and this ring right here, which moves back and forth to activate these fingers as the motor switches from repulsion mode to induction mode, the ring still moved forward, but since these were all corroded, it just smashed that. So I'm going to go through each one of these fingers and make sure all the parts are straight and flat. We'll get that straightened out. So that explains part of that. I'll go ahead and get that done. Okay, we're getting our brush holder put back together. I got 4 replacement springs for this. They're not exactly the same as the originals, but they're pretty close. I think they'll work out okay to what I had on hand without running to the store. Got our brush holder finished up. Went ahead and I adjusted each one of these mechanisms, and they're all operating okay. Nothing's binding up. Now when we put this back together, I'll put some new brushes in here. These are the ones that were in there. Whoever put these in there, they fit, but they don't fit great. See all that play in there? They're a little short from front to back, and they fit a little too sloppily in there. Now they should move freely in their holders, but not that freely. So we'll put some new brushes in there and we'll size each one to its respective holder and make sure it's moving perfectly in there. Also, when I lubricate these little points on these fingers, I like to use this synthetic clock oil. It's really a great oil. One thing that makes it ideal for this is that oil doesn't really dry out. It doesn't get gummy over time, and it doesn't attract a lot of dust. When you're lubricating the fine movements on the clock, you really need some high grade oil. And this oil is a little bit expensive, but it's perfect for this kind of thing where you don't want the thing to get gummy and you don't want it to attract dust. Anyways, we'll carry on to the next part of the project. I'm making a new nut, and I got the piece indicated in the 4-jaw chuck, and now I'm just boring it out, and then I'll use a 3/4 16 tap to make the threads, and I got to put a groove in there and a couple dimples for the spanner wrench. There's our finished nuts. I made one with the groove there in the middle, and I made one without the groove there on the left. When I put it back together, I may end up using the one on the left with the snap ring, because that one with the clip in the middle, that was really difficult to get off of there. And in the future, if I need to work on that spring or replace it, it may be easier just to use the snap ring. Anyways, once I get it back together, I'll figure out which one of those I'm going to use. But they came out looking pretty nice. All right, we're going to get started taking this rotor apart. And the first thing I'd like to mention is that you may recall at the beginning of the video, I said that I had found a screw in the Endbell when I was taking it apart, and I didn't know where it was from. Anyways, it appears that it fell out of the rotor right there. So we have that screw. Another thing that I'd like to point out is if you look at this rotor, it's not the same as a Century motor design. The default position of a rotor on the Century motor is with the shorting necklace retracted. So on the Century motor, as the motor comes up to speed, the flyweight's open, there's 2 push rods in there, and they push the shorting necklace forward, and that shorts it out against the commutator, and then it switches over to induction mode. Looking at this motor, we could see that this rotor, the default position on this rotor is in an extended position, okay? You can see the shorting necklace is right here. It's away from the commutator. So on this motor, when the flyweight's open, the shorting necklace will retract, and then it'll make contact with the commutator. So it's just a small difference. One positive thing about this design is you don't have to worry about the force of that spring. On the Century motor, when you take this apart, the spring is compressed, and consequently, when you take it apart, it's coming apart with a lot of force. So you got to be careful when you're taking it apart. But on this one, the spring is extended, so there shouldn't be any real spring pressure in there when we take it apart. So we're going to start taking these screws off, and we'll see what we find in there. I have never taken this rotor apart before, so it'll be the first time. I'll be learning as we go. All right, you can see right here, there's a hole on each side of the shaft for a spanner wrench to go in. So we're gonna try to take that plate off. It is under a little bit of spring tension, so I do got my safety glasses on in case that thing comes flying out at me. Luckily, it's not rusted on there. There it went. That nut did the job. Okay, now let's see what we got here. It's a pretty beefy spring. Okay, that's it for that. I probably have to turn it over on the other side to disassemble it further. We got the rotor flipped over. You may recall in some of my other videos I mentioned that you cannot proceed with the disassembly until that big spring is out of there, because the big spring holds these flyweights closed and you can't access the screws or cotter pins or whatever is holding this whole mechanism together. So now that we have the big heavy spring out of there, we can get these flyweights open. Hopefully everything is pretty corroded in here. There's one, there's two, and there's a couple screws in here. There's two on this side and two on this side. And when we remove those, hopefully that'll get these weights out of here. Let's try it and see what happens. Well, it's not too bad. Okay, with those screws out, that just lifts it up. It was held in place with this pin. Let's see if we can get the other one off here. There it is. Okay, let me clean this up a little bit and take a look in there. See what we need to do to proceed. I'll bring you guys back. Okay, this is a real small space in here, so I'm going to tell you what I'm going to attempt, and then I'll bring you back after I've attempted it, because I can't get the camera in here and my hands at the same time. So if you look right here, there's a pin that runs through this part right here, and that pin is retained with this little piece that pivots right here. So I'm going to try to take this piece, I'm going to try to pivot it out of the way, slide that pin out, and then hopefully that's going to free up the connecting rod that's holding the assembly in on the other side with the shorting necklace. And there's two of these. There's one on this side also. So it's very small in here. So I'll attempt that and I'll bring you right back. I was able to get one of the pieces out. Here it is right there. And there's the pin that holds it in position. Now that pin is captured in there when they assemble the rotor and they press this end piece in there. That pin cannot be removed. On this side, I was unable to get that pin moving. It's completely corroded in there. I would have to use a torch on it to break that free. But the risk of using a torch on here is not worth any reward of removing that piece, because the risk of damaging the windings is too great. So I'll just leave that in there. This thing pivots perfectly fine. I mean, there's nothing wrong with it. I'll just clean around it and lubricate it in place. So that's as far as we're going to break this rotor down.
We're doing some general cleanup on the parts for the short-circuiting necklace. We're going to make a new spring here a little bit. What I'm doing now is I'm cleaning up all the individual contacts. That's real important. A lot of times you'll see people just take the entire necklace and throw it into an ultrasonic cleaner. That's really not good enough. If you look at this, you can see how oxidized those were. You got a nice clean one. That makes a world of difference as far as your electrical contacts are concerned. So it's a little tedious, but we'll go ahead and get each one of those cleaned up. And that way, when we put it back together, it'll be working like brand new. In the process of making a new spring for the short circuiting necklace, if your spring is really stretched out, it's always best to count how many individual coils you have so that you get an accurate length on it. This one's not too bad. It's a 6-inch spring. This is a 3/16 of an inch spring, and it's about 30 thousandths of an inch thick. So I just ordered an extension spring from McMaster Car. Comes in like a 36-inch length. They're less than $10. You can get several springs out of it. And to join it together, I cut off a little piece of this number 8 bolt here. All you need is a half a dozen threads. I got it threaded in on one side. I'll loop it around, thread it in on the other side, and then secure it with a little Loctite. It'll be good to go.
Now that I got a handful of those contacts into position, I put that purple rubber band around there. It's easier to use a rubber band than it is to put the spring back in place because the rubber band is a little bit more forgiving while you're putting it back together. Once I get it back together, then I'll swap that out and put the spring back on it.
Oh, that good.
We got the commutator turned down in the lathe, and that's as far as I want to take it, even though there's still some scoring in here, and there's still some pitting inside here. I mean, that thing was really scored up bad and pitted bad in there because those Endbells were welded on there. I mean, it was really arcing and sparking and created a lot of deep grooves in the commutator. But the further you take that down, the thinner this gets, and you can't put material back on. This will have no impact on the way that this motor runs. So we're just going to leave that right there. I think that's the best happy medium. And I left this inner ring a little bit proud so that there's a little bit more material for that shorting necklace to sit on. So I think that that's going to work out just fine.
I'm in the process of undercutting the mica between the commutator segments. And although you could use a hacksaw blade, or you could go on eBay and find an old undercutter kit, the best way that I've found to do it is using one of these little hobby knives. You can get like at Hobby Lobby or someplace. They're cheap and they work great. They're thin, they're rigid, they get right in between these sections. So I'll demonstrate on one right here for you. So I'm on this one right here. Get started here. Then we gradually work our way forward. These have real fine teeth. And at the end, once I get all these cut, I'll have to polish up the commutator anyway, just to take off any burrs or if you slip with the blade or anything like that. So it'll need to be polished up once we're finished. Now we'll take it like this, work our way forward. Just want a nice groove in there. Got a good separation, just like that. Check it with my fingernail, make sure it's good, which it is. That's it. We'll move on to the next one. After I'm done with that, I'll put the commutator back in the lathe and we'll just polish that up. So full disclosure, when I was polishing that commutator, I forgot to cover my ways, and I always try to take meticulous care of my ways, and I got some abrasive on them. So before remounting this rotor, I took everything apart, cleaned the ways, re-lubricated them. Anyways, onto this part, you could see that that shaft is completely destroyed. I mean, it's just been mangled. So what we're going to do is, this diameter right here is 5/8. The original diameter of the shaft was 7/8. Some 1.5 horsepower motors do come with a 5/8 inch shaft, but the thicker shafts, which is usually put on your motors that have a higher starting torque, gives you a little extra rigidity for like side loads and things like that. So what I'm going to do is I'm going to take the shaft. First, I'm going to cut 2 inches off of there. This is 5 inches. It only really needs to be about 3 inches. Some of your organ blowers and some compressors had an extended shaft, but this motor is going to be retired, so a 3-inch shaft is more than adequate for it. I'm going to go ahead and turn that down, get that cleaned up, and then we're going to press fit a sleeve on there. We'll leave it finished up at 7/8 of an inch diameter, and that new sleeve will just look a lot nicer. I'll use the Loctite makes a special retaining compound that's made for press fits, and it's an excellent product. It's very strong. So we'll press a new sleeve on there with some of that special Loctite in there, and it'll be good to go. Alternatively, you could actually weld this, bring that back up to size and then turn the welds down. But you definitely wouldn't want to do anything like that on a motor that's this old, and you run the risk of warping the shaft. It's way too risky. So we'll turn it down and sleeve it. I'm going to get started on that right now. Okay, we got the shaft turned down. You can see here I cut that piece off. This is turned down to 5/8, and I put a new center in there. So now we're going to take the armature out of the lathe, and we'll start working on our sleeve that we're going to press on that turn down shaft. We're going to start working on the sleeve for the shaft. I got a 1-inch piece there of 1144 stress proof. It's a nice machining material. Should give us some good results. So let's get started. Okay, we got the inside of our sleeve covered with the Loctite 680 retaining compound. And as I mentioned before, that is specifically designed for this type of application. We got a liberal coating on the shaft. I also drilled and tapped a 1/4 hole in here. Since there's that little flat remaining on there, I might as well utilize it and add a mechanical fastener on there with a set screw. I mean, it's really not going to need it. But this fits on there real nice. Okay, that's good there. Now we're going to take our set screw, put a dab of red Loctite on it here. And when I turn down the outside diameter of the sleeve, I can turn down the set screw at the same time. Although this will be recessed in there. That's it. Let that set up. Take it back to the lathe.
While I got the 4-jaw chuck on the lathe, I got to bore out the pulley just slightly to accommodate the new shaft we put on the motor. I got this dialed in within 1/1000th. Not bad for a cast iron pulley. So we'll get this bored out and I'll put it on the side. It'll be ready to go. Go ahead and turn it on. Hold on to it until it engages. There you go. That's good. Leave it be. Now you're going to watch your dial over here, okay? And when that gets to 0, we're going to turn it off.
Yeah.
Okay? And don't touch the machine while it's moving. Just watch it. Alright, let's see how we did. That is a perfect fit right there. Beautiful. Okay, we'll put that pulley aside and we'll carry on with the reassembly of the rotor. All right, so to get the spring back into the armature requires a little bit of fooling around on these larger motors where the spring is real thick and heavy like the one we have here. So if you have a large press or something like that where you can fit the entire length of the shaft in there and you can press it down while turning it, you have to use a spanner wrench on it while you're doing it. My press is about an inch short. I can't quite get the entire length of the shaft in there, plus a socket or something to push the spring into position. So I just got it chucked back up in the lathe, and we're going to use the tailstock kind of like a little press to push it into position. So we're going to take our spring, put our spring in there, and then this threaded collar is what secures it into position. And now I'm going to try it without the spanner wrench first. I'm going to see if I could just turn it into chuck. Maybe the pressure will get that started. If not, we'll have to put the spanner wrench in there too. So we got to get this in there. It's got to be in there just like that. Now I'm going to pull up the tailstock, tighten that down, nice and snug. Okay, now we're going to start cranking her in until it fits in there just right. Just like that. I'm going to go until it stops, which means we're at the bottom of the thread. Probably right about there. And now I'm going to try to turn the chuck, or to turn the shaft with the chuck and put that on there. See if it gets. Okay, I got it that time. That took me 3 attempts to get that. They said it is a real heavy spring. So now I'm going to back off this tailstock. And you can see that our collar is threaded in there, right there. Okay, now I'll go ahead and I'll take my spanners and get that tightened up a little bit further, and we'll be good to go. Now that we got the armature back together, I'm focusing my attention on getting some properly sized brushes for the brush holder ring. I have boxes of carbon brushes. Anytime I'm at a flea market or someplace and I see them for a good deal, I buy them. Because just buying one of these big brushes for a Century motor will cost you more than I paid for that whole box. Anyways, looking at the old brushes, okay, these do not fit correctly. See all that gap back there? And you see the side-to-side play on that? Those are a little too small. So I'm going to take these are a hair too big, which is what you want. You want to start out with something that's a little oversized, and then I'll sand it down to fit. I'll fit each brush to its respective holder. I'll actually number these so that each brush will be custom fit for its respective holder. And once I get that together, we'll be able to start some assembly on the end bells. Another thing I have to whip up is a couple felt seals for the bearings, for the grease seals. That shouldn't be no problem. I got some felt floating around. So I'll get something whipped up, and we'll start getting this thing put back together. All right, with our gaskets completed, it's time to start doing some final assembly work on this. Anytime I'm working on these motors with real heavy rotors, I always like to set the rotor in there first, and then we'll put the end bells and everything on kind of around it. So we're going to carefully put this in here. If I block the camera, I apologize. This rotor's pretty heavy. I want to try to do it in such a way that I don't damage our beautiful windings that we worked so hard on. Okay.
That looks pretty good right there. Now carefully set our end bell into position. Get my holes lined up here. Kind of get these bolts started here. Now we're going to carefully, and I do mean carefully, try to get this thing into position here. Okay, start with that. I already got some anti-seize on these bolts. Okay, I got the motor back together, and if you recall in the beginning of the video, there's an issue with something binding here, and I was explaining that if you watch the commutator here, you'll see the commutator moves, but you can see the shorting necklace is not moving, okay? And that problem existed in the motor before we started, and now we got brand new bearings, we got everything put back together, and as you can see, problem is still persisting. So now is going to come a period of taking this thing back apart, and we're going to try to see if we can get to the root of the problem. We know everything's good as far as the bearings. Our alignment is as good as it's ever been. What I'm going to do is I'm going to take out the brush holding ring, and I'm going to put the motor back together without that ring in place and see if the problem persists. I have a feeling that when this motor was cracked in a bunch of different pieces, this back end bell, that in the process of putting everything back together, that something is probably just out of alignment, and it's possible that this ring right here is rubbing or binding against the shorting necklace. So by removing the shorting necklace and putting it back together, if the rotor spins freely, we'll know that the problem is somewhere in the shorting necklace. So we're going to start taking this thing back apart, and we're going to start the process of troubleshooting that binding, and we'll see where it takes us. To start troubleshooting this situation with the commutator, I removed the brush holders off of this ring and just loosen that up so I can kind of see what's going on in there, and I think I see what the problem is. So the problem is not the ring itself. The problem is this right there. If you look at that steel part underneath there, okay, it's hitting the back end bell. You see that? And that's causing that to bind up. Now it'll turn if I force it, but that's not correct. And as mentioned earlier, it was doing that before we ever took this motor apart, so it's not something that we created. So now I'm going to have to take the motor back apart and try to figure out why the rotor is not sitting forward as far as it should be. Everything looks to be okay. We have brand new bearings in there. So let me go ahead and take it apart, and we'll take a closer look and see if we can figure out a way to get that rotor to move forward slightly. Okay, so I think what the problem is, I think this steel ring right here needs to be flipped around. Now I put this back together exactly the way that we took it apart, but I think it was put together backwards before we got the motor. So I'm going to confirm that. I do have a couple other of these motors. I'll confirm that, but I'm pretty sure that's what the problem is. This recess is supposed to be flipped around to move that whole mechanism over a little bit. So let me get that flipped around, and we'll get this thing put back together. Okay, that did the trick. That's what we want to see right there. When the rotor moves, the necklace moves. We got it all buttoned back up. I got all the grease wells filled up with grease, and I think it's good to go. The only thing that I have not done on it, and I'm going to do this in a couple months, is I have not machined a flat on that shaft to accommodate the set screw on the pulley. I do have a brass set screw in here just so it doesn't mar up that shaft,
But within the next couple months, I'm getting a brand new milling machine, and that'll be the best way to mill a flat on that. So once I get my milling machine in a couple months, then we'll get that milled in there. But in the meantime, with that brass set screw, that new shaft is not going to get marred up. Here's our connections. I got it wired for 220 right now. This motor is going to be retired. I mean, it's had a hard life. So I just got it wired for 220 because it draws less amperage that way. It only draws half the amps. But it still runs good. You can see the back side. So we'll get it set up. And you can check it out running. Okay, now we'll do an across the line start. And remember, because it's hooked up for 220 and we're running it on 110, it does take an extra second to get up to speed. I mean, that thing is running nice and smooth. Got no complaints about that. I realize this is a very long video, but this was by far the longest restoration project that I've undertaken with the antique electric motor. I have well over 120 hours worth of work on this thing, and the video only reflects, 1% of that. This motor needed so much work with that rear end bell being cracked in 6 different places and then being welded on. I mean, there was, as you saw in the video, there was just so much to do with this thing. Every step of the way, there was a challenge, but we got it done. And I think if Harry W. Jeannin was alive today, he'd be pretty happy with the outcome of this. You won't find another video on YouTube of one of these motors being torn down like that. They're so rare. So this is a one-shot deal. This will be the only video you ever see of one of these motors. Anyways, thank you for sticking with me on this one. I hope that you enjoyed it, and I look forward to seeing you the next time. Thank you very much for watching.